Okay, welcome to Foundations in Pre-Calculus Math 10 with Mr. Johns. Today we're doing the last section of Chapter 2, and this is Section 2.7, which is solving problems involving more than one right triangle. So we're going to use trig ratios to solve problems that involve more than one right triangle. Basically, we can use the information from one triangle to solve the other triangle. So it's kind of two problems in one, but as long as we work carefully through it, we should have no problems. So let's solve a problem with two triangles. So number one here says to find the measure of angle F. Well, we have only one bit of information about angle F, or about this triangle, so we would like another piece of information. What we can do here is find this side using this hypotenuse, and then we'll have opposite over adjacent for this angle. So here we go. We want the sine of angle D is going to equal opposite over hypotenuse, which is equal to side EG over DG. So the sine of 34 degrees here for angle D is equal to EG, which is our missing opposite side, over the hypotenuse, which is 14.4 centimeters. And now we're going to have to multiply both sides by 14.4 to figure out what our missing side is. So 14.4 times the sine of 34 degrees is equal to EG. So 34 sine, and then times that by 14.4. And I have 8.052378, I'll say. Now, I found this side to be this amount, and I can use that information here. So 8.052378. The reason I'm not rounding off at this point is I want as much information as possible to get this angle to be as accurate as possible. So now, relative to this angle, I have the opposite side and I have the adjacent side. So I'm going to use the tangent ratio. So the tan of angle F is equal to the opposite over the adjacent, which in this case, tan of F is equal to side EG over FG. So the tan of F is equal to 8.052378 over 9.6. And to bring tan across the equal sign, angle F equals the tan inverse of our number here, 8.052378 over 9.6. Luckily, I still have this number on my calculator, so I'm just going to take this number, divide it by 9.6. This equals this decimal, then shift, tangent, and I get angle F to equal 39.9896 approximately, which is basically 40 degrees. There we are. We found angle F. The next problem is going to deal with angle of elevation, and basically the angle of elevation is if we're looking up at something, it's from the ground up to our line of sight. Okay, so now we're going to solve a problem involving the angle of elevation. The angle of elevation of the top of the tree T is 27 degrees. So that's the smaller angle here. From the same point on the ground, the angle of elevation of a hawk, H, flying directly above the tree is 43 degrees. That's the bigger angle. The tree is 12.7 meters tall. How high is the hawk above the ground? Give your answer to the nearest tenth of the meter. So, I think what we need to do is figure out another side that is shared by these two triangles to figure out HG given TG. And the side that I'm seeing is QG. If we knew this, then it's adjacent to both angles, and we could figure out the opposite angle, or the opposite side relative to the 43 degrees. So, tan Q is equal to the opposite over the adjacent, which is TG over QG. So, angle Q equals 27 degrees, and TG equals 12.7 meters. So we'll substitute those in. 27 degrees, TG is 12.7 over QG. I'm going to multiply both sides by QG to bring it to the top. And then I'm actually going to divide both sides by the tan of 27 degrees to bring it to the left side. So, these reduce, and I have QG equals 12.7 divided by the tan of 27 degrees. So let's do that. 12.7 divided by 27 tan equals 24.9252 approximately. So 24.9252, and we want to figure out Hg now. So this is in meters, and now our unknown is here. So I have the adjacent side. I want to know the opposite side, so I'm going to use tangent again. So the tan of angle Q, which is 43 degrees, is equal to Hg over Qg, which is 24.9252. Well, now I can multiply both sides by 24.9252. And this should give me my missing height of the hawk. So here I still have my number unrounded. I'll take it and multiply it by 43 tan equals, and I get 23.2431 approximately. To the nearest tenth of a meter is 23.2 meters above the ground. So there is the height of the hawk. It's higher than the tree, so my answer seems to be right. Okay, the last thing we need to know is about the angle of depression. And this is if we're looking straight, angle of depression is the angle from our line of sight downwards. So let's solve a problem that involves the angle of depression. So, this diagram shows a falcon on a tree with a squirrel and a chipmunk on the ground. From the falcon, the angle of depression of the animals are 36 degrees and 47 degrees. How far apart are the animals on the ground to the nearest tenth of a meter? So they want to know how far apart they are here. Well, basically to me, I have to figure out GS, and then I can figure out CG and subtract it from GS. So CS equals GS minus GC. So the angle of depression of the squirrel is the smaller angle, so 36 degrees. To figure out the right angle triangle here, we need to go 90 minus 36, which is 54 degrees. So this angle is 54 degrees. And I'm trying to figure out this side, which is opposite, and I have the adjacent. So the tan of 54 degrees is equal to GS over 15. I'm going to multiply both sides by 15. That's going to reduce. So 15 times the tan of 54 degrees is equal to my unknown side. And so 54 tan times 15 equals 20.6457 approximately. So that's this total distance from G to S. The angle of depression for the chipmunk is 47 degrees. And 90 minus 47 will be 43 degrees. So that's this angle here. I want to know the opposite side, and I'm given the adjacent. So again, I'm going to use tangent. So the tan of 43 degrees is equal to GC over 15, which is our adjacent side and not the hypotenuse. Multiply both sides by 15. So 15 times the tangent of 43 degrees equals our GC. So 43 tan times 15 equals 13.9877 approximately. And this distance will be 20.6457. This is in meters. Minus 13.9877. They want the nearest tenth of a meter, 658 meters, which is about 6.7 meters apart. There we have it. That was a tricky one. Okay, your assignment for this last section. This will be good practice with trig. We'll do 2.7, number 1, and then I'd like you to try number 3. We'll leave number 2. Good luck. Let me know if you need help, and we'll start the chapter review right away.